All right, folks, I do expect everyone to take some notes on this material and then do the problems that I've assigned you in Pearson. Thanks for watching the video and giving it your best shot. Look, we know a basic area formula, right? If I know what the height of this triangle is, and I know what the base of the triangle is, okay? Well, we know the formula is 1/2 the height times the base, right? All right, so that's easy. Like we're trying to find the area of a triangle, but we're going to use two different forms, not the basic form. So let's say we only knew the base down here, but we knew. So I'm gonna give you some numbers actually. So let me switch to like let's say this is 10 long, and let's say this is a 50-degree angle right here, and we know the other side over here is, let's say, 6 long. Okay, so how would I find the area? Well, I'd try to find the height, right? So how could I find the height? I've got a little right triangle right here, right? Couldn't I say the sine of 50 degrees is equal to h over 6? So let me put that right up here, that the height, we could always do this with a triangle. Like if we knew that angle and we knew this side over here, we could find the height, right? So we'd go, well, first let's write it like shoot. Hold on a sec here. Let me undo that, what I just wrote there. And let's just write down the sine of 50 is equal to h over 6. And now, couldn't I just multiply both sides by 6? So I get h is equal to 6 times the sine of 50. And I would replace the h right up here with 6 sine 50, right? So let me do that right here where the h is. I'm going to replace it with this guy. All right. So I end up with 1/2 6 sine 50, and then I have it times 10 right down there. So let's call this 6 side like A, side A. And let's call this angle C. Okay, so let me put a C right here. And then this would be angle B up here, right? And this is angle A over here. So this formula that I just kind of wrote down right here is really, it's 1/2 the sine of C, right? And then it's times the 6 and the 10. Where are the 6 and the 10? It's A and B. It's the two sides that make up the angle. It's the sides of the angle, right? So it's 1/2 the angle, the sine of the angle, times the two sides that make up that angle. Now, the lettering doesn't matter, really. The lettering doesn't matter. Like if you had a triangle that looked like this, and you had like this side over here, and you had this side down here, and you have this angle, those are the three pieces of information you need. You need the angle and the two sides that make the angle, okay? So I don't want you to get hung up. The book has 3 different equations. They just manipulate the letters that are sitting right there, right? Okay, so how about another formula? Now this one, I'm not going to do a proof of. I tried to do a little proof up here, that you could always just take this angle and use the basic SOHCAHTOA and say the sine of the angle is equal to the opposite leg over the hypotenuse, all that jazz that I just showed you right here. I'm not going to show you the proof for Heron's formula because it's kind of weird. So first of all, there's a square root involved. Where does this formula come from? It comes from the law of cosines, and it comes from one of those half angle identities that we had back in chapter 7. So, cosine has the c squared, all that kind of stuff, bunch of squares in it. So that's where the square root kind of comes from. And then this S is the semi-perimeter. It means we're going to have all 3 sides. So we're going to use form 2 when we have all 3 sides of a triangle. And back here on form 1, we're going to use that when you have 2 sides and an angle and 1 angle. And it's got to be like this. It's got to be side, angle, side. It's got to be the angle that's included between the 2 sides, right? So down here, we have 3 sides. We don't have a single angle. So you're going to find the semi-perimeter. So let's write that down. S equals half of all three sides added up, A, B plus C, okay? And you're going to multiply that by S minus A and S minus B and S minus C. And like I said, I'm not doing a proof of it. It will find the area of a triangle where you know all three sides and not a single angle. Okay, so you're going to give it a shot today in Pearson. I've got a bunch of problems I want you to try for the area. Thanks for watching the video. Appreciate it.